Okay, welcome functions folks. This is lesson 1.6 on dividing polynomials. Today's a pretty big day. We figure out what it means to divide polynomials. We know how to multiply. We've known how to multiply binomials and stuff like that for a few years. Grade 10 perhaps we learned how to do this. So this is going to be a review of grade 10 stuff, but then we're going to figure out how to go the other way, which is dividing, right? Multiply to expand though. We multiply everything by everything, right? So multiply everything by everything. I get x squared minus 1 plus 2 is plus x minus 2, and that's in brackets, and that entire thing has to get multiplied by the last bracket. And I'm going to do something a little bit different. I'm going to write this in a different way. When I multiply out, I'm going to multiply everything in the first bracket by x, so I get x cubed plus x squared minus 2x. And then I know 4 times all these things, but I'm going to do something a little bit different. When I write them down, I'm going to write them kind of next to the like term. So 4 times x squared is 4x squared, of course. But you see how I'm kind of going to line that up. And then 4 times x, 4x, and then 4 times minus 2. And why the heck did I do that? Well, essentially now I can just add down. My like terms are down instead of, and that's no biggie. That's no biggie, but it's kind of like a little shortcut that helps us. And then so therefore, I've got that expression is equal to that expression. Now, what's the moral of this story here? Well, the moral of this story is this function for us, easy to graph. This function, not easy to graph. At least not with the same detail. We could have all the x-intercepts of this one we don't know. And have a look at this one. From last day's stuff, we sort of figured out, well, we'll have to factor that so we know where the zeros are. But notice I can't factor this by grouping. There's no common factor. It's not quadratic form, and so I'd be stumped on how to graph that one. So we need to figure out how to go from an expression like this to an expression like that, and that's what the next couple of days is all about. And it's a little bit strange and wonderful, folks, so strap yourself in and enjoy this ride. And this is exactly what I said. So to graph these things, we need to factor, but how? And it says factoring involves dividing. So we have to figure out how to divide polynomials, and that's what today's all about. Is 27 a factor of 4,298? Well, this is old school long dividing, and if you can't remember long dividing, well, I'll go through fairly slowly, I hope, because as it turns out, the process of dividing polynomials feels a lot like the process of long division. And I know it's been a long time since you did long division, and we'll go through it fairly slowly. So what's the first step? The first step is to figure out how many times the quotient here, the number I'm dividing, goes into, well, it doesn't go into 4, but I go into 42, and it goes in once, right? So I just decide how many times does 27 go in, right? That's the first question. And essentially, the whole idea of long dividing is breaking these pieces up into smaller parts. Well, and then what do I do next is, well, I write down the 27. Now, that 27 is actually, I multiply, right? I multiply 1 by 27. This 1 times 27, and I write that down there. And then I subtract, right? I subtract down this way. Subtract, I get 15. So how did I get that one? I subtracted. And notice that the answer that I got here was less than what I was dividing by, and that's an important step in the long division process. Well, how do I continue? I see I got all these other numbers. Well, what I do is I bring down the next number, right? Do you remember this? You know, I can almost hear the groans out there in Cyberland somewhere. I bring down the 9, and then I go again. Then I start the process again. How many times does 27 go into 159? Well, and then we want to figure out the biggest without going over, right? So it's 5. And then I go 5 times 27. 5 times 27. Multiply, and I get this number in here, which is 135. And then, so when I subtract, I have to get a number that's less than 27. So that's going to be 24. It's almost not big enough. And then that should have been in red too if I was going to follow the color scheme from before. And then I bring down the 8, and I'm almost done here. Right? I bring down the 8. How many times does 27 go into 248? Well, it goes 9 times. And it's a factor, remember, if there's no remainder. That's 243. And that was the multiply. I'm not going to follow my color scheme. Why not? I can still follow my color scheme. Why not? So this is 9 times 27 is my 243. And then when I subtract again, and that's where I got the 24 from, was subtracting. Subtract. And I'm going to subtract again here. Those are the steps. And then nothing to bring down, so I'm done. So the question is, does 27 go into 4,298? No, 27 is not a factor, because there's a remainder, right? If it had a remainder 0, it would go evenly. In fact, I could write, if I wanted to, that 4,298 is 27 times 159 plus 5. And check that on your calculator. This is true, right? The big number is what I was dividing by times what I got plus the remainder. And then we'll see that this is going to be an important statement for us soon. Why did we go through this? Well, our next task is to do this using polynomials. How is that going to work? Well, this polynomial divided by this, it's a long division thing. And it's going to be exactly the same process as we use for long division, except for it's going to be using algebra. So we thought, well, how many times does x plus, well, x plus 3 doesn't go into x cubed, right? So we got to use two terms. How many times does x plus 3 go into x cubed minus 2x squared? Well, that we don't know. That doesn't make much sense. But what we want to do is we want to have something here, so when I multiply and subtract, this number's gone. That's the idea of the subtract being less than what we started with. So what would I need to multiply by so when I subtract, I end up with a 0 right here? Well, if this was x cubed, it would work, right? So what would I multiply by? X squared. And let me show you how that works. X squared times x plus 3 is x cubed plus 3x. Well, that was right here. I have x squared times x plus 3. And once we get used to this, by the way, you're not going to write these steps in. You're just going to be able to do this. And then my next step is to subtract, right? When I subtract, the x cubes are gone. That's the whole reason why I did this, right? Because now I'm going to have a one-term expression instead of a two-term that I started with. So when I subtract, negative 2x squared, subtract 3x, negative 5x, watch your signs there. Okay, so then I subtract. That's the next step. Well, what was the next step after that? Well, I need another term so that I can figure out x plus 3 going into. So what do? I bring down the next term. Oops. That was supposed to be a square. Did you notice that mistake? Yeah, x squared. And notice there's a lot of patterns that go on in this dividing business as well. And we'll mention those as we go. So now, what do I write up here so that when I multiply x plus 3 by it, I'm going to end up with negative 5x squared. Well, hopefully you can see it's going to be minus 5x, because when I multiply minus 5x by x plus 3, the first term will cancel out. Right? And again, once you get used to this, and it's a strange thing, I realize that this is a strange process, but like any new math, it's a little bit strange to begin with. So negative 5x, and I did that so that first term would cancel out when I multiplied or subtracted. Here, see, that first term has to be the same. And then when I subtract 14x, subtract 15, be careful there, 14 subtract negative 15, that's positive 29x. Bring down the, and that should have been in red. That was a subtract there. And then we're going to bring down the minus 1, and we're almost done here. So what do I multiply by so that when I subtract I can get rid of the 29x? Well, 29. 29, and I here, see, I'm starting to get lazy already. Again, once we get the swing in the swing of things, we won't write all these steps in. We'll just think them. And 29 times 3 is 87. So when I subtract, I get negative 88. So notice, what does this tell me? That means that this doesn't divide evenly into this. In fact, we have that the big polynomial is equal to what we were dividing by times the answer, and then a minus 88 on the end. Okay? This is my big polynomial. This is what we call the divisor. B at x, it's just a function of x, the divisor. This is q at x, which is the quotient. The answer to a divide question is a quotient. And then this is the remainder. What's the remainder? There's no x in it, but sometimes there will be. We'll see. And this is what we call a divide statement. All right, and that, I know it's going to take a little bit to get used to this style. We've got a couple of more examples coming up in part 2 of the video, so yeah, be patient with this, folks. It'll take a little while to catch on. Part 2 coming up.